number 9. It says use a calculator. So that means you need a calculator. So press pause and get a calculator. Find the average or mean value of log x from 1 to 4. So in order to find the average value, it's an integration problem. And we're going to integrate from 1 to 4. We're going to integrate the function, which is log x. And then we divide by the difference of the bounds. So this is the setup. It's a little formula. It's not that complicated. So we're integrating from 1 to 4. That's the function we're finding the average value of. And then you divide by the difference of the bounds. And now can you use your calculator to get the answer? So let's do the second part. So press pause if you don't have your calculator and work with me. Let me clear this up. All right. So first I'm going to divide. So control and divide sign. And then I'm going to go menu. I'm going to go calculus and integrate. And then my lower bound is 1 to my upper bound, which is 4. It's log. If you want to know where log is, it's right there with the 10 to the x. See that in blue, log. So press control and 10 to the x. It's a common logarithm, so you can leave the base empty. So there, the base is 10, so you can put 10 there or leave it empty. And then just x, and that's dx. And then the denominator is 4 subtract 1. That's it. So if you leave it empty, it puts 10 in there for you. Same thing. And then the answer is 0.368. That's it. Don't forget the dx. So 0.368. Done. Number 10. In number 10, it says, find the x value, which produces the average value problem in number 9. So to find that x value, you take the function, which is log x, and make it equal to the average value, and then use your calculator to solve that equation. So how do I do that? So, and what I'm going to do is, I'm going to copy, paste, and use the full number in my equation. So I'm going to go menu, and this is algebra. We're going to solve an equation. And the equation is log. I'm going to leave the base empty, x. And that's equal to, so move the cursor, make sure it's still inside the big parentheses. And then I'm going to copy paste. So I'm going to come here, I'm going to double click on this, highlight it. I'm going to go Control C, that copies it. Then I'm going to come back here, click on it, and then I'm going to go Control V to paste it in. And then make sure you go comma X, and then go Control Enter. And so at what X coordinate does the average value occur? So it's about 2.335. You can truncate or you can round. All right, number 11. For these are review questions now. So up to number 10 was the lesson questions to go through, which was on finding the area between two curves and the average value of a function. Now these are review questions. So can you differentiate, anti-differentiate, just practicing? What you don't practice, you forget. So it's really important that if you want to get the most out of this, that you first try it before you let me do it for you. So if you want to learn the material, then you need to press pause and try it. Or if you don't know how to start it, I'll start it for you and then press pause and try it. The more you do on your own, and the less you just copy what I do, the better. So in this situation, let me show you my work. So if I want to take the derivative of this, first thing I notice is the denominator is a monomial. And because of that, I can write this as 3 separate fractions. So let me write that for you. And then you can reduce it down. And the reason I write it as 3 fractions is to make the derivative easier. So I'm going to simplify that. So x cubed divided by x squared, that's just 3x. this, subtract the exponents. 1 subtract 2, that's negative 1. And then 1 over x squared can be written as x to the negative 2. So we write it in a way where you can do the power rule simply. So now the derivative of 3x is 3. So what happens is, if you integrate, then suddenly your brain forgets how to take the derivative in terms of what you've done before. So make sure you feel comfortable taking the derivative and the antiderivative. So 3x is 3. The derivative is that we multiply. So negative 1 times negative makes it positive. And then you subtract 1 to the exponent. So again, negative 2 times in front is negative 2. And then you subtract 1 to the exponent. It's not difficult, but when you don't practice, you're going to forget. Number 12. So again, the best is if you try it first and learn it. And then if you can't, you can't. So can you press pause and take the derivative, or do you need my support to begin with? So the first thing I do is I make it calculus friendly. So square root, I write to the exponent 1/2. To take the derivative, it's the power rule, but there's a chain involved. So the power rule, this is the general power rule, is 10 times 1 in front. Subtract 1 to the exponent. That's the general power rule for taking the derivative. But then there's a chain involved. So whatever the base is, that's connected as a hook-on factor. The derivative of x is 1. The derivative of negative x to the half, it's 1/2 times negative 1. That's negative 1/2. And then you subtract 1. So 1 take away 2 is negative 1 over 2. No plus c or anything like that. We're taking the derivative, and there's your answer. Number 13. Again, we're taking the derivative in number 13. These are such important questions to review so that you don't forget the basic rules that we've done before. Obviously, when you take the exam, when you go to university, you're going to be required to know all of it, right? So you can't forget what we did in August or summer or in September. And the only way we don't forget as we move forward is by practicing. So number 13, it's ready to take the derivative. I see the exponent 2/3, which is nice. This is what's called the product rule. So I'm not going to simplify it, but the product rule is the first times the derivative of the second, which is 2/3, 2 subtract 1, and then you subtract 1 from the exponent. That's 2 subtract 3, so that's negative 1/3. And then there's a hook-on factor. The derivative of 2y is 2. The derivative of negative 1 is 0, so I don't need that. So that's the first times the derivative of the second, doing the power rule with a hook-on factor, plus the second times the derivative of the first, which is 3y squared. Perfect. Number 14. Again, I'll just keep reminding you, in case you don't, it's best if you press pause and try it first. So 2t subtract 1, 3t squared plus 5. So what do I notice right away is that the denominator is a binomial, so it makes it challenging to separate this into different fractions to make it easier. So the binomial, 2 terms in the denominator, pretty well clears the way that this is going to be what's called the quotient rule. So I don't have to simplify it, but what is the quotient rule? That's the bottom. Again, press pause if you want to try it first. The bottom times the derivative of the top, subtract the top, times the derivative of the bottom. And then the bottom squared. Done. And don't even bother by simplifying it, but do you remember the quotient rule and how to set it up? Number 15. Now for these questions, 15 to 18, it's the antiderivative. So you're given the derivative and can you work backwards? So let's look at that and how I would handle it. Oops, here we go. So the first thing I look at here to do the and the antiderivative is to add 1 to the exponent and divide. We might have to do the anti-chain rule, is I do see a monomial in the denominator. So the way it looks right now, I'm not comfortable taking the antiderivative of it, but I recognize with some algebra I can make this easier. The numerator I can FOIL, and you need to be able to FOIL this pretty quickly. Like, there should be no reason that you can't go from here to here quick. That's just good basic algebra. It's x squared, negative 2 and negative 2 is negative 4x, and then negative 2 squared is 4. Nice and simple. And then the square root of x here. Now, what we're going to do is, now we have a monomial. I'm going to write this as 3 fractions to make it easier. So, and I'm going to write this as x to the 1/2. So we have x squared over x to the half. We have 4x over x to the 1/2. And we have 4 over x to the 1/2. So I wonder, can you now press pause and do the next step where you simplify this so we can do the antiderivative? So when the bases are the same and you're dividing, subtract. So 2 take away 1/2 is 1.5 or 3 over 2. We have 4. Now the exponents is 1 take away 1/2, which is positive 1/2. And then the last one, we have another 4. And then all we have is x to the half in the denominator. So to write it without a fraction, it would be x to the negative 1/2. So, I mean, that's good algebra skills, right? To have that ability to go from here to here. So then, once we have that, now we can actually integrate this. So, if I integrate y prime, what would that now look like if I integrate it? So, I'm going to add 1 to the exponent. So, I'm going to go 2 plus 3. So, that's 5 over 2. And then you divide or times the reciprocal. Same thing here. Add 1 to the exponent. So 1 plus 2 is 3 over 2. Divide or times the reciprocal. Notice how I left a little space there. And I don't even bother to simplify unless I have to. The next one, again, I'm going to leave a little space. Add 1. So negative 1 plus 2 is positive 1/2. Divide or times the reciprocal. But for this, we do need to have a constant at the end. So it's a general antiderivative. It's not a definite integral, so we need to not forget the candy at the end. And I don't need to simplify it, and there's your answer. Number 16. So again, the best is when you try it first. Let me write down number 16. It's x squared plus 3 to the 5. So if I'm going to do the antiderivative here, I recognize that this is going to be the anti-chain rule. So the derivative, I need to set up the hook and then unhook it. So to set this up properly, so first of all, what we're doing is we are integrating. So if I want to integrate this properly, the derivative of x squared plus 3 is actually 2x. So the derivative of x squared is 2x. Now, we need a fraction in front, so they stay the same. So it was 1, and it became 2. So the fraction in front is going to be 1/2. Then I unhook 2x, and then I simply apply. So when I do the integrate a derivative, it's just f at x now. Unhook it, and then I just have to add 1 to the exponent. Leave a little space here. So I'm going to add 1 to the exponent, which is 6, and then divide or times the reciprocal, and then don't forget the constant. And yes, you could write that as 1 over 12. Number 17. So you're given that g prime at y is 4y, and I'm right away going to write it different. So it's 4y, and I'm going to write that as y squared plus 3, but I'm going to write to what exponent, so it's not a fraction. So that's to the exponent negative 1/2. Now, I'm going to integrate this. And so when I do that, the derivative, so I'm going to integrate this. So when I take the derivative of y squared, that's 2y. That's the hook that should have been there. And when I look at the difference, what was it before and what it become, I'm going to go 4 divided by 2 so that it stays the same. So if I went 2 times 2, it's the same equation, but now I can unhook this. So unhook 2y, and our answer is going to just be g at y equals, and it's going to be 2. All right, leave a space, and then we're going to add 1 to the exponent. That's positive a half. Divide or times the reciprocal. That's where the 2 comes in. And then don't forget the candy. And you could also just put a 4 in front there. All right, there's number 17. Number 18. Did I mention that you should press pause and try it first yourself? All right. This one says be careful. Darn it. I just want to not think and do it. Just kidding. So I'm going to write it as t plus 3 to the negative a half. The challenge here is that the hook here, the terms don't match. So the hook for t plus 3 is 1, and that is unlike t. So this is not the anti-chain rule, because when I take the derivative of the base, it does not match. They are not like terms, so then I can't change it with a constant. So I can't do that. This is unfortunately what's called a U-Substitution. So because of that, they're not like terms. What's inside the parentheses, which is t plus 3, we're going to do it together, okay? So that's u is equal to that. Then I'm going to see what t equals. So I'm going to subtract 3. And then I'm going to take the derivative. So the derivative of t, the derivative of u, and then negative 3 is just 0. I'm going to do a substitution here. So instead of t plus 3, it's going to be u to the negative a half. Instead of t, it's going to be u minus 3. That's why I kind of put a space there in front. So t is u minus 3. T plus 3 is u. And then this should say dt. If I'm integrating this, there's good symbols. dt is just du. So that's what h at t equals. Now, before we can actually do the antiderivative, now comes the algebra part. So we're going to distribute. There's an exponent 1 there. So when you multiply and do the distribution, you add the exponents. So that's to the positive a half. Negative 3 times this, they just go beside each other. And that's what I'm going to integrate. So to integrate this, we're going to add 1 to the exponent and then times the reciprocal. We're going to add 1 to the exponent and then times the reciprocal. And then don't forget the candy. This is an indefinite integral, so that means I do need to substitute t back in. So u is t plus 3. So make sure you put t plus 3 back in for your final answer. Oops. There it is. Done. And I'm always checking to make sure that I match the answer key, which it does. I know, that was tough, but we did it together. Number 19. Now our limit questions. Man, it's been forever doing limits. So limit as x approaches 2 from the left, and it's an absolute value question, so that always involves a graph when it's absolute value. So in this graph, x subtract 2 divided by x subtract 2, if I understand this correctly, when x is 2, the answer is 0. But it's 0 over 0. So it's undefined. It's indeterminate. Now, if you plug in a number bigger than 2, you get a positive divided by a positive. Like no matter what number you plug in, you're going to get positive 1. This is actually yuck. Just there. So at positive 2, it's indeterminate. So we're going to put a hole there. And then to the right. And then if I plug in a number smaller than 2, like positive 1, you actually end up with a positive divided by a negative. So any number smaller than 2, you ended up with an answer that's negative 1, because the numerator is always positive. So this is what the picture looks like. And then it says, what's the limit as x approaches 2 from the left? So from the left, what's the y value as you approach it? And the answer is negative 1 from the left. In number 20, it's the same one, but it's now approaching from the... Now it's just 2. So it's not the left or the right, it's both at the same time. And so if it's not a one-handed limit, if it's both, if it's just 2, this limit does not exist because the right does not agree with the left. So because of that gap, there's a jump, and because of that jump, this does not exist. All right, there's 19 and 20. That was a long time ago we did those kind of questions. 21, the limit as x approaches 1, x squared plus x minus 2 over x minus 1. First of all, it's a substitution question. And as you substitute in to find the y value, you will find it's indeterminate. So if you plug in 1, it's 0 over 0. Do not write down 0 over 0, because that is bad mathematically. Just know it's indeterminate. Next, what do you do if it's indeterminate? Well, we look to see if we can factor. We're actually going to have another method coming up called L'Hopital's rule. But right now, we don't know L'Hopital's rule. So we're going to factor this. That's positive 2. And negative 1. And then notice that this simplifies. And now you can substitute in. So you can remove it. Because there's a removable discontinuity, there's a hole at positive 1. You can remove it. The limits still exist. Plug in 1 and you get the answer 3. 22. The limit as x approaches negative 1, the square root of x plus 2 subtract 1 over x plus 1. So step 1 again, if you plug in negative 1 and simplify it, plug in negative 1 and simplify it, it's indeterminate. It's 0 divided by 0. There's no factoring here. So the only way to do this is what's called the conjugate. So it's been a long time, so I know you forgot. It's okay. The conjugate is the square root of x plus 2 plus 1. And then that's top and bottom. The square root of x plus 2 plus 1. Now, for some, I'm going to simplify, and some I'm not. So when I write this, the numerator, I'm going to simplify. So this now is the difference of squares. You go first times first. The square roots undo each other. And then go last times last, and it's simplified. The denominator, just put them beside each other. There's no need to multiply that out. I want you to notice the numerator becomes x plus 1. Well, they then can eliminate, and now you can plug negative 1 in and get your answer. So your answer is going to be negative 1 plus 2. So that's the square root of 1 plus 1. That's 2, and you have your answer. So the answer is 1/2. 23. We're almost there. Oh boy, there's like a lot of pieces to this. Okay, 23. It says f at x equals, and there's 4 pieces. We have x squared subtract 3 when x is smaller than 1. 4 when x is equal to 1. Negative 2x between 1 and 2. And negative x cubed plus 8 when x is greater than or equal to 2. And then part A says, what's the limit as x approaches 1? So even though there's lots of pieces, it's a simple question. The limit as x approaches 1. What it's equal to at 1 doesn't matter. It's the left and the right that matters. So when you plug in 1 on top, what answer do you get? So that's negative 2. Plug 1 into this part, because this is the right side. So the left and the right, what it's equal to doesn't matter. So plug 1 in, you get negative 2. You get the same answer, because left side equals right side. The limit exists, and the answer is negative 2. So, and we can show it this way. It's good to show your work. So 1 from the left equals negative 2. 1 from the right equals negative 2. Therefore, the limit exists and the answer is negative 2. Part B. What does part B ask? The limit as x approaches 2. So for this limit to exist, we have to look at the limit from the left. So what's the left for 2? That's this piece right here. This is the left. So plug in 2. So negative 2 times 2 is negative 4. Plug in the limit as it approaches from the right side. So where do I substitute in for the right side? That's here in the denominator, the bottom piece. That's it. So plug 2 in. Now 2 cubed is 8. So it's negative 8 plus 8. That would be 0. So does the left side agree with the right side? No, so this limit does not exist. And you show your work to know why it doesn't exist. 24. So in a lot of ways, these review questions are the most important because you have to practice or you'll forget. Find the domain, the vertical asymptote poles graph, and in the graph, the intercepts and behavior symmetry. Then sketch its graph without using a calculator. So y equals 4. No actual calculus here. Not increasing, decreasing, not maximum or minimums. None of that. This is pre-calculus. So step 1, not using calculus tools, can you graph this? So I'm going to factor out a 4. That gives me x squared subtract 4. The denominator is the difference of squares. That's x squared minus 4, x squared plus 4. Now, I already noticed that these eliminate. Now, what eliminates, what's the 0 of what got eliminated? And I want you to notice there are 2 holes in this graph. So what you eliminate is x squared subtract 4, make it equal to 0 and solve it. Where do you have holes? Is that you have holes at positive 2 and negative 2. So what's left over here? Oops, that is so wrong. X squared plus 4 is not factorable. I just did a faux pas, as they say. All right, so 4 over x squared plus 4, not factorable. Just write it that way. So if I want to know where the holes are, plug in positive 2. And if I plug in positive 2, I get 4 over 8, or a half. The other one is negative 2. Well, negative 2 gives me the same answer, which is 1/2. So those where the holes are. I want you to notice we have no vertical asymptote. So x squared plus 4, there is nothing that makes the denominator 0. So if I'm thinking of the domain, the only 2 numbers x cannot be are positive and negative 2 because they create holes. But we have no vertical asymptotes. But we do have a horizontal asymptote. Because the denominator is more powerful than the numerator, the horizontal asymptote is y equals 0. What didn't I find yet? Oh, the intercepts and the end behavior. So this is the end behavior, where the right and the left end are approaching 0. The intercepts, we have no x-intercepts, because we just have a constant in the numerator. There's no way to make the numerator 0. And the y-intercept, plug in 0 for x, and you get 4 divided by 4. So at 0, 1, we have a y-intercept when you plug in that. And that's it. So then we're going to put all of this together and graph it. So I'm going to do that here. So if I graph this, what do I know so far? I know there's, I'm going to change colors here. So let's label some of these things. So we have holes at -2 and a half. and at positive 2 and a half. We have a y-intercept here. And we have our end behavior, our horizontal asymptote is at 0. Now, if we did more calculus tools, we'd have a better understanding, but just connect the points. And then we could look at concavity, point of inflection. Seems obvious that there's a maximum right there, that we can use calculus to confirm that. And there's the graph. 25. In 25, we have x squared plus 3yx equals y squared plus 3. And the question, and we have a point 1, 2. And the question is, find the equation of a tangent line. That's another way of take the derivative and then make an equation of a line out of it. So how do I take the derivative as a good step? So that's 2x. This is the product rule. Now the product rule is the first times the derivative of the second plus the second times the derivative of the first. Now, the derivative of 3y is 3, but because y is involved, this is done implicitly, you need a y prime hook on. So the derivative of 3y is 3, but it needs a hook on of y prime. Just like here, the derivative is 2y, but it needs a hook on of y prime, and then the derivative of 3 is 0. We need to gather up the y primes. So put them together on one side. So I'm just going to keep them. I'm going to move this to the right just because. So we got 2x, 3y times 1 is 3y. I'm going to subtract and put them beside each other. And then I'm going to factor out a y prime. So just factor out in front. You get 2y minus 3x left. And then the last step is to divide to get y prime. So there's the derivative. 2x plus 3y divided by 2y subtract 3x. So now we have the derivative done implicitly. We have a point to plug in. So to find the slope at 1, 2, where there's an x, you plug in 1. Where there's a y, you plug in 2. And then simplify it. So plug in 1 for x and 2 for y and simplify. That is 2 plus 6, which is 8. 4, take away 3, which is 1. So the slope there is 8. And now we have everything we need. So we have x is 1, y is 2, and the slope is 8. What's the equation of a line using those numbers? So it's y equals 8, x subtract 1 plus 2. Done. And I know it's challenging. The challenging part is taking the derivative implicitly. And then when you plug in the point, that's easy. And then once we have all the numbers, it's super easy to write the equation of a line. All right, number 26. 2 left. In number 26, if f at x equals x subtract 1 to the 2/3, the mean value theorem does not apply to which interval? So to understand this, x subtract 1 to the 2/3, the mean value theorem, there are two conditions for that to work. This is when a rock equals I rock. Now, that's the average rate of change equaling the instantaneous rate of change. It must be continuous, and it must be differentiable for this to work. Those are the two conditions. Now, x subtract 1 to the 2/3 is continuous everywhere. In fact, if I graph this for you, it would kind of look like a curved V. Do you remember that kind of looks? Well, I think it looks like a seagull, but it looks like a curved V. That's what this looks like, 2/3. It's actually been shifted 1 to the right. So let's write it properly. So if I graphed it, it's been shifted 1 to the right, where that vertex then is right there. And that's what it would look like. So that means shifted 1. That's what the picture of 2/3 looks like. Can you see that it's continuous, but it's not differentiable there? So at x equals 1, it is not differentiable because of that cusp or corner, because the right does not agree with the left. So this right here, it's not differentiable. So the MVT doesn't apply in the interval that includes 1. So for A, when it says 0 to 2, and the other one says B, and it's 1 through 9. So let's talk about the easy one to begin with. So for this one, 1 is in between 0 and 2. So for here, it does not apply. And the reason is it's not differentiable at x equals 1. So in the middle of the interval, it's not differentiable, so the mean value theorem does not apply. In part B, it's a little confusing. But because we're starting at 1, because 1 is where we're starting to 9, because we're not involving the left and the right, it's just starting at 1, going to the right. So because it's starting at 1, going to the right, it then does apply. So from 1 to 9, it is continuous and differentiable. Because we're not involving the left and the right, then differentiability doesn't come into play. So this one is yes. It's a little confusing because 1 is part of it. But from 0 to 2, it's obvious that 1 is in the middle of it, and it's not. DNA, I don't even know what it should stand for, but I'm saying does not apply. Last one. And the y part is it's not differentiable at x equals 1. 27. And if you write it mathematically, this is a great way to write it, that as 1 approaches the derivative from the left, it does not equal the derivative from the right. That's a beautiful way to show that it's not differentiable at 1, and therefore it doesn't apply from 0 to 2. Last one, 27. For problem 26, use the interval in which it does apply, that's the second one, to find the c values where the derivative is equal to the average rate of change. All right. So we have a function again. Remind myself of this. It is x subtract 1 to the 2/3. So to find the value where it exists, where a rock equals I rock, I need to do two things. I need to take the derivative. That's 2/3 x subtract 1. Subtract 1 to the exponent. So 2 subtract 3 is -1/3. There's no hook-on factor because it's 1. The second part is the slope formula. And so because we're going from 1 to 9, the slope formula then is f at 9 subtract f at 1, and then 9 subtract 1 in the denominator. So that's just the average rate of change, or the slope formula, y2 minus y1, x2 minus x1. That's the setup, and then we solve it. So we have 2/3 x subtract 1 to the -1/3. If you plug 9 into the function, 9 take away 8. 9 take away 1 is 8. And then how do I do 2/3? So it's 8. The cube root of 8 is 2, and 2 squared is 4. That's how you do it. 1 take away 1 is 0, and 0 to any exponent is 0. 9 take away 8. 9 take away 1 is 8. And now we're going to solve this. So on one side we have 2/3 x subtract 1 to the -1/3. On the other side we have 1/2. And I want to get x by itself. So I'm going to multiply by the reciprocal. They eliminate. This is 3/4. Next, I'm going to undo the exponent by raising both sides to the exponent -3. So when I raise it to the exponent -3, the exponents undo each other. So I have x minus 1. And on the right side, the negative exponent means reciprocal. And the exponent 3 means 3 times 3 times 3. So that's going to be 27, but in the denominator. This is 4 times 4 times 4. That's in the numerator. And then the last step is just to add 1. And that's it. You could make common denominators, but that's numerically equivalent and it's over. So at that value, A rock equals I rock. And then in the question it says C. So 64 over 27 plus 1. That's the C value where A rock equals I rock. Done. Hey, your assignment's done. I am beyond proud of you that you're doing your work. I'm hoping every time that you press pause and try it first, I hope these videos help. I hope you're learning calculus. I really do. Till next time, Mr. G Math.